We have another example on the board. I'm going to start solving this problem from finding the value of resistance and value of the impedance of the inductor. Please notice that we have given voltage across the resistor and we have given voltage across the inductor, and we have also given current. By using Ohm's law, I can find the resistance and impedance of the inductor. So if R is equal VR over I, which is equal 60 volts over 2 milliamps. This is equal 30 kilo ohms. ZL is equal VL over I. Someone is going to ask, what current is it? Is it I total, or this is IR, or this is IC? At this moment it doesn't matter. Why? Because we are talking in terms of the series circuit. In series circuit we have just one current. So that's why I'm not going to name it, just to make, extra exercise for you to realize that the series circuit has just one current. So I have 75 volts over 2 milliamps, which is equal 37.5 kilo ohms. And don't forget that when we talk about the impedance of the inductor, we're supposed to always include angle of 90 degrees. Next, we're supposed to find Z total. Z total is equal resistance plus ZL, because this is series circuit. So I have 30 kilo ohms plus 37.5 kilo ohms and angle of 90 degrees. This is equal 48.02 kilo ohms and angle of 51.34 degrees. This is Z total in my circuit. Next, I'm supposed to find the voltage source. Voltage source is equal I times Z total. I'm going to use Ohm's law, of course, where I is equal 2 milliamps times Z total, which is equal 48.02 kilo ohms. Again, I'm going to assume that the voltage source is supposed to have angle of 0 degrees. Why I'm doing that assumption? Just to make our calculations a little bit simpler. So, just plug in these values into the calculator and you're supposed to obtain the value of 96.04 volts and of course angle of 0 degrees. This is my voltage source. Because I have voltage source and I have Z total, I can find the angle which is going to appear next to the current. Please notice that we said that I represents also I total, this is also IR, and this is also I, because this is series circuit. Current is equal to voltage source over Z total in this case. So I have voltage source which is equal 96.04 volts over the Z total, which is equal 48.02 kilo ohms and angle of 51.34 degrees. Now, those of you who are experienced with these kind of problems, you're not supposed to do extra calculation like I'm doing right now. I'm doing this especially for those of you who still have difficulties to see how to get the angle, which I'm supposed to write next to the current. So, if you are going to perform the division, you're supposed to obtain 2 milliamps, and of course this is 0 degrees. Subtract the angles, you're supposed to get negative 51.34 degrees. I'm supposed to subtract the angles because we talk about the division. So anytime you divide the two polar forms, right? Two complex numbers expressed in polar form, you're supposed to divide the magnitudes and subtract the angles. That's why I said subtract the angles. So I found the current. Next, I can find the voltage across the resistor and voltage across the inductor. So VR is equal IR times resistance, where IR is equal 2 milliamps and angle of negative 51.34 degrees times the resistance, which is equal 30 kiloohms. This is equal 60 volts and angle of negative 51.34 degrees. So this is my voltage across the resistor. Next, we're supposed to find voltage across the inductor. So if VL is equal IL times ZL, which is equal 2 milliamps and angle of negative 51.34 degrees times ZL, where ZL is equal 37.5 kiloohms and angle of 90 degrees. This is equal 75 volts and angle of 38.66 degrees. This is my voltage across the inductor. And someone is going to say, yes, I can go ahead. But it's always good to verify your answer. How you can verify your answers? By using KVL. Okay, if you are going to add these two voltages together, you're supposed to obtain the voltage source. And if the value which we are going to obtain is going to match to 96.04 volts, means that our calculations are okay so far. So we have voltage source is equal VR plus VL, where VR we found is equal 60 volts and angle of negative 51.34 degrees plus VL, which is equal 75 volts and angle of 38.66 degrees. This is equal 96.04 volts and angle of 0.0001 degree. So we consider this as 0. So I have 96.04 volts. This is my voltage source from this addition. So it means that our calculations are okay because our voltage source is equal 96.04 0.04 volts, and after adding these two voltages together we get the same answer. So far we are okay. Next we're supposed to find the frequency in the circuit. Okay, frequency of the voltage source. So I'm supposed to use the formula for the impedance of the inductor. ZL is equal to 2 pi FL. In order to find F, I'm supposed to divide both sides of my formula by 2 pi L. 2 pi L. Cancel, cancel, cancel out, cancel out. So I'm going to have F is equal ZL over 2 pi L, which is equal ZL is equal 37.5 kilohms over 2 pi times L, which is equal 500 microhenries. This is equal 11.93 megahertz. Okay, so this is the frequency in my circuit. Next we're supposed to find omega. Omega is equal 2 pi F. So I have frequency, 2 pi is constant, so I have 2 pi times 11.93 megahertz. This is equal 74.95 times 10 to the 6 radians per second. This is my omega. Next, I'm supposed to find the power factor. The formula for power factor says power factor is equal cosine theta. So I have power factor is equal cosine of the angle which is next to z. So I have z total, of course. So I have cosine of angle 51.34 degrees. This is equal 0.624, and of course lag. Again, let me remind you, we're supposed to use word lag because my angle is positive and because in RL circuit current lags the voltage source, okay? So that's why I'm supposed to use word lag. Next, we're supposed to find the true power. True power is equal IR to the second power times resistance, where current in the circuit is equal 2 milliamps. So I have 2 milliamps raised to the second power times the resistance, which is equal 30 kilohms. This is going to be 120 milliwatts. Next, I'm supposed to find the apparent power S. S is equal I total to the second power times Z total, which is equal 2 milliamps raised to the second power times Z total, which is equal 48.02 kilohms, is equal 192.08 VA. Now we can say that the problem is solved.